Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. Today we are going to attend this example number 2. This is the system of couple ODE with the algebraic properties at infinity, and this equation it is a coupled equation and involving the algebraic properties at infinity. You can see here this is the differential equation of coupled differential equation involving uh, two unknowns, and that is f and theta, and their boundary conditions are here. We want to solve it through the pvph2. For this purpose, where we are these kinds of the primes, where the primes denote the derivative with respect to similarity variables. Eta sigma is the punctal number, f of eta and theta of eta related to the velocity profile and temperature distribution of the boundary layer respectively. Leo 5 employed the HAM to solve the system analytically. Now we use the BVPH2 to solve it under the transformation. We use this transformation, that is the xi equal to 1 plus eta of this, and this term in this form, and equation 10 and 11 become in this form. Okay, you people don't be confused how we change this. Is we just transform this equation by substituting new xi equal to 1 plus eta of lambda, lambda of eta, and this is these things are used in boundary conditions and also being, and we transfer the equation in this equation 10 and 11 in 14 and 15. Now we are going to solve it with the help of first question is that why we use the transformation. Okay, you can see here this is the third order differential equation involving firstly theta, and this the equation involve two unknown in one equation, and furthermore it has two, and here you can see there is also be two, but this is the second order differential equation, and this is the third order differential equation. And after by using the transformation, and the third order differential equation reduced to second order, and it is a one step simplification of the results. But today we don't want to focus on the transformation, what kind of transformation is used. We are not interested in it, but we are going to solve our problem with the help of the BVPH2. Our focus is only to BVPH2. For this purpose, you people should know this is the differential equation, and with subject to the boundary conditions. This is the boundary value problem, and we want to solve it, boundary value problem. First of all, we write the type EQ. I am going to change this in equation 1. In place of 1, I write 2 because I want to save it in 2. And now control and new file is open, and I copy these code. You can write down these code by yourself, or you can download this example. This is the first one, type equation 1, and number of equation is 2. Here you can see the number of equation is 2, and this the type equation is 1, and there is a no unknown parameter involved here, due to why we write type equation is 1. Every unknown, let's suppose here you can see the lambda and the sigma, they are known values, so we can't be used here too. Next one is the boundary condition. There are 4 boundary conditions are involved. You can see here the problem is that this is the, we paste it. After that, now you can see here there are 1 2 3 4 5 boundary conditions, but here is the 4 boundary condition because there are 2 second order differential equations. combination of the two second order differential equation. Now this is the setting of the if you want to more explanation about this, you can see example 1 that present on the education for all, and you can see and you can understand. This may be about nearly about 1 hour lecture. Here is the what is meant by the ZL. ZL mean to say there here is right is 1. 1 mean to say here is involve F, and the second is S. 1 mean the F, and 2 mean the S. Its starting value is 0 and ending value is infinity. There is left value is 1. Left value is it is starting value is 1 and ending value is infinity. And now the starting values is 1 and ending value is infinity. After that we substitute the z right integral of 1. Right integral of 1 mean to say we want to mention this condition in the form of some specific value, because we can't be handle the infinity, due to why we substitute the value of infinity. In place of infinity we replace is 10, and z right integral into is 10. We put it both of starting and ending points, both are capital F and S are same. Now I am here, and this is the very important thing, that is the gases over gases. But these gases involve some another extra value. What is that value? Is the gamma. The third, choose this, and this is the auxiliary linear operator we choose here is, this is the auxiliary linear operator. You can see here I copy and going to paste. Okay, but you people can see here is a gamma. What is gamma here? And you can see this is the equation, and in this equation this is the sigma, and you can see here there is no gamma involved in our differential equation. And how this is given to us, because this is the our initial approximation, and we use it. If you people see the first lecture about pvph2, I explain why you compare both the result in example illustrated example and the example number 2. You can see that why we use gamma or alpha in that place. Okay, and the gamma function is basically discussed here is a convergence control parameters, and this is going to be in generally without loss of the generality. Let us consider the case when gamma sigma equal to 1, gamma equal to 3, and lambda equal to 1 over 3, involving here some kind of let's suppose why we use here the lambda and this is the sigma. This is sigma and lambda. Here you can see that we choose the values of these one. These polynomial parameter are the control parameter of C naught of k as defined as. If you people can view about you can see the method of Ham, and if you know about that, you can see in the paper in which we involve the convergence control parameter. For this purpose I am using gamma here. Why we in the first example we use alpha, here I am using gamma. Now this is the this is there's values, but question is that how we choose the convergence control parameter. How we take the C01 is minus 1 by 2 and C02 is minus 1 by 2. In the other hand, in the first example we can't use these things. We calculate it by using this formula, but in this case I am substituting these values. How we know these values is here. For this purpose you can see the example our first lecture about BVP H2, and you can see this one how we choose it, and what formula is used to calculate this. And we furthermore discuss this will discussed in next few lectures, and we are talking about the convergence control parameters. That is most important for you for learning the pvph2, also be the homotropy perturbation analysis. Now we copy this one, and we are going to enter here and write pvph and this one. To get the 20th order approximation, if you are not satisfied with the accuracy of the 20th approximation, we can 21 to 40 in date of 1 to 40. If we, to get 40 order approximation or higher order approximation. Note that 1 to 40 and 2 to 40 are the 40th order approximation of the transform system 14 and 15 and 16. To plot the curve of the 40th order approximation for the original problem, we first replace z with 1 plus eta lambda of eta to obtain the 40th order approximation f prime of eta and g of eta. For the plot of the curve, we want to write down in mathematical as following. Because you people know our original problem is this one. This is the original problem, but we transfer this problem in this form, and due to y, when we get the result of this problem, we are going back and substitute in place of hexi is this one, and after substituting this we get the result. That's mean to say we z approaches to 1 plus lambda into eta in place of this due to y, and plot evaluate and this command. You people may understand why we do this. This is due to y, because we initially transform the equation, this equation, in this form, and the transformation units are these. So why when we calculate the result in the form of xi, we change xi. Here is xi is used as z. Now z is transformed into this form, and how we transform it, this is the transform shape. After that we are going to plot this one, getting the results and plot. You can see here plot. I am going to copy and paste it. This is the result paste, and this one is the error total, and this command is used. This is only for the calculation of the error, and you can see here the error report, and this is the HP report, and this is the plot again. This one is the HP. You know about the HP, and today I will discuss you again this HP command, and but I am here to run this one. Now I am run it. You can see here the result is the some empty folder, and there is not boundary condition already satisfied. And what is this one? This is to be very different situation. Now I am going to evaluate and quit. And this is the local and exactly done. After that we run this example, but you can see here there is a problem, that is the get cannot open this one. Why? Because we can't save the previous file. I am going to first of all, this example is save. Now going to save, and with the name of example, and not only example, this is example2, this is example2, and now I am going to again save as, and write it the name with example2, but you should have to mention here this is the M file. Now I save it. After save this result, you can see I'm going back and run this first. This is first run. I run it. Okay, I make a mistake here. No, this is the successfully run. Now I'm moving on my problem, that is the example2. I show you the first, by increasing their size. Okay, I mention here, and you can see the problem is that the graph is empty. It's mean to say it is not study the graph very well, and what happened with that. Okay, due to this problem we can handle it. This is due to why, because you can see here the 1 to 40 1 to 40 and we use pvph 1 to 20. For this purpose you should have to use 1 to 40 and run it, and this is going to launching 4 kernels, but this is a warning. It is satisfy, fourth condition satisfy and get constant, there is a no solution, और यहाँ से ये this one is aborted. Aborted mean to say the result is not calculated and it is out of our range. And now okay, let's suppose we are taking this example, and S2 it is right way boundary conditions, and the boundary condition is already satisfied, and now this is the U, second one, and dash. This is the second boundary condition has already satisfied, and the fourth boundary condition already satisfied. And let's suppose we are talking more sufficiently to say the BVP 1 to 5 and run it. It will also be satisfied. G minus 1, Z approaches to 1. Okay, we are focused on our boundary condition, what kind of mistake we make here. This is our problem, and you can see that in our problem, this is the problem, and compare both the result. In this example you will see here f1 equal to 0, here is the boundary condition. F this one is equal to 0, but we mention here it sorry, this is 1 and it is right. Second one is G at 1. G at what is meant by the G here is to say G is any constant, and G at infinity. We mention here G, but where is G? Okay, we are making a mistake here. We use two function f and s. Here we use the in place of s is G. It is the mistake, and we need to correct this one. If we further make any kind of mistake, then we will now this G is replaced by capital S, and this G is also replaced by capital S. Now we run the code, and there is aborted, and higher order approximation is this one. Now I replace this, and then I am going to quit local and this one, and first of all I run my basic command. I run it. Okay, it's okay, close, and next one to run it, shift enter. It is going to be running. Okay, it is launching the fourth kernel, but get constant, there is a no solution. It is not a solution possibly. Now we are going to change this. These are the S. Now this person is also use the U, and also B. Where is the function of U? Is launching the sigma 1, gamma 3, lambda 1 by 3, talking. This is a ZL S. Okay, we are start from here. We can see what kind of mistake is making in this code. One mean to equation 1, Z underscore it is right, f has lambda is equal to lambda square derivative of 2 times derivative s minus f square. Okay, f of 2 into Z underscore in lambda square in this, and sigma fs. Number of boundary conditions are 4, that is 1 2 3 4 fs, and this one f, this condition on this term, and this is there. Okay, that's mean to say we are going back and see this example. In this example you can see when we use the boundary conditions, you people can watch f and g, but when use the G, we also be use the boundary condition. Here is the G. Here is involving G, same kind of the function that involve on the left and on the right. There is a three conditions: first, second, third, 4, 5, and 6. Four conditions are total condition are 6 total, and 4s are F or and 2 are on G. Same way, in same way you can see two condition on F and two condition on S. We need there here is the derivative involves, but number of derivatives. The number of derivative is the second, two derivative, and also be S have two derivative. So the conditions are 2, 2. Okay, I'm going here and look at this. This is the F and theta. Here is F and S. Yeah, F have two condition. It means that is right. Here this man make a mistake on place of S. He write G, and after that maybe he make another kind of mistake, that is Y 1 2 Z Z. It is right. Okay, for the purpose of understanding this the mistake, what kind of mistake he make on it, is going to be code. And talking about example 2, maybe this is the illustrative dot m. First example, example 1, example 2. We can see here he is using right and he make a mistake again. In this way is okay, this is right. Right, he write this one in very proper way, but in that place here this man make a mistake. Okay, we copy on this place and run it. The example 2, what is there, this is the copy. I show you again, control N. Yeah, when you make any mistake, then you demand to yourself that you may you have nothing to do maybe in your problem, and this is the reason you. Okay, this is the selection portion. I copy the selected portion and paste it in here. You can see the I am going to save it, save as example 3, but we are going to save example 3. This is the example 3. Sorry, this is example 2. I am writing this 2 1 2 1 because these are two examples involving in it. I run it. Okay, this is running. This is running and completely running. The second one we already satisfied, and this is the warning message is also give us. Now what kind of the error is occurring? No, I